All right, guys. Today you're going to be taking a look at how to convert between degree and radian angles. I'm going to go through a couple of examples, and then I'll also talk about some finding coterminal angles. Okay, so let's quickly go through this. You should have watched the introductory video about radians and degrees and the relationship between the two. And so what I want us to take away here is the conversion factor. It's basically pi radians equals 180 degrees. And so I've set it up this way for your notes. If you are trying to convert from degrees to radians, essentially what we need to do is multiply by pi divided by 180. And so what that looks like here, multiply by pi divided by 180. Now, this 65, right, it's over 1 if nothing's written in that denominator. And so the way we do this is multiply across. 65 times pi is 65 pi. Let's leave it like that because we want a nice exact answer. And then 1 times 180 is 180, okay? And we can go ahead and try and simplify the 65 and the 180. And if you divide, I guess, 65 by 5, what you'll get is 13. Keep the pi, 180 divided by 5. I picked 5 just because these are both multiples of 10, and you should get 36. And that would be the degree in radians, or the angle, excuse me, in radians. Okay. Then going the other direction, right? Radians to degrees. So this is clearly in radians because we have some type of pi. Now, unless there's a degree sign, you have to assume that it is in radians, that the angle is in radians, unless there is a degree sign, okay? It doesn't have to have a pi in it to be radians. It just does not have to have a degree sign, okay? And so in order to convert this radians to degrees, we're going to take our conversion factor, except if you notice here, it's just the reciprocal, right? And the reason why, a good way to remember it is when you're going this direction, right, the pi's are going to cancel with each other, right? And that's good because we don't want any type of pi in our degree, okay? You can cancel the pi's now, or you can do it at the end. I'm going to do it at the end, so I'm going to take 3 times 180, and what you get there is 540, and then you've got the pi, and then 4 times pi. And again, you'll see here now the pi's cancel. You're left with 540 divided by 4, and then you can simplify that to 135 degrees. Okay? So that is how we convert between degree and radians and vice versa. Right? So let's take a look at finding coterminal angles. Okay? So let's start off with a basic definition here. A coterminal angle, and you know, the example sheet before, you were just looking at how to draw positive and negative angles, right? So if this is my initial side, I've got my XY coordinate plane, I'm going to draw an angle maybe of, let's say, 120 degrees this way, and it stops there. This is 120 degrees, right? A coterminal angle is any angle, right, that ends up in the same ending place. And that starts in the same place and ends in the same place as your original angle that you're looking at here. So, for example, a coterminal angle with 120 could be, I could go around the entire circle, that's 360, right? Like that. And then end up going another 120. Okay, so if you see this, the angle I just drew was 120, well, actually 360 plus 120 degrees. Okay, so I went around a full circle and then another 120 degrees. Okay, and so what that ended up with is an angle measure of 480, right? So this all the way around is 480. But it's a coterminal angle with 120 because it has the same initial side, right? And it has the same terminal side, right? It's just a different degree measure, okay? So a coterminal angle here will have the same initial and terminal side, but a different degree measure. Okay. All right, so this example was in terms of degrees, but basically to find any coterminal angle, you are either going to add or subtract 360 degrees. There are an infinite amount of coterminal angles with other angles. Okay, so you can add and subtract as many times as you want, right? I could have gone around this so many times and still ended up back at 120. Now, you can either add 360 or 2 pi. You add 360 when your angle, and typically we use theta to represent an angle, so when your angle is in degrees. You use add or subtract 2 pi when your angle, theta, is in radians. Okay? All right, so it's not too bad. Let's take a look at an example here. It's asking for a positive and a negative angle that are coterminal with 45. Okay, well, if I want a positive angle that's coterminal with 45, this is in degrees, right? So I'm going to add 360 degrees, okay? And what that will give me is 405 degrees. That's a positive angle. I could do the same thing, except it wants a negative now, so I'm going to subtract 360. And what that will give me is a negative angle of negative 315. Okay? Now you can draw these, and I promise you they will all end up with the same initial and terminal sides. Okay? So this one's not so bad. It gets a little bit harder when we're dealing with fractions, adding and subtracting in radians. Okay? So first, let's do positive. We've got pi over 6. I'm going to add 2 pi to it. Okay. Now, this is 2 pi over 1. In order to add, you have to have a common denominator, right? So I'm going to get a common denominator here. If this is 6, this one needs to be 6. So I need to multiply this by 6 and also this by 6. Okay? And so what this will look like, 2 times 6 is 12 pi over 1 times 6 is 6, right? And then we're going to add across while keeping our denominator the same, right? Now this is a 1 pi. 1 pi plus 12 pi gives us our 13 pi over 6. And that is a positive coterminal angle with pi over 6, okay? We're going to do the same thing, except we're going to subtract pi over 6. Now since we already got our common denominator, I'm just going to use the 12 pi over 6. But again, that's just 2 pi, right? Except now instead of adding, we're going to subtract. And again, this is 1 pi. So 1 minus 12 gives us a negative 11 pi over 6. And there are 2 coterminal angles. Alrighty, so you can go ahead and stop the video, and good luck on the practice problems.